Here is a walkthrough of this practice sheet for graphs of polynomial functions. This first section, we're just identifying whether we have linear, quadratic, cubic, or quartic, and then we want the degree and the leading coefficient. So number one, this is linear, and that is because the degree is 1, the exponent on x is a 1, and the leading coefficient is -5, the coefficient on the x term with the largest degree. Number two, we want to focus on that term that has the largest exponent on x, so that's 3/4 x to the 4th. So that means this is a quartic, has degree 4, and the leading coefficient is 3/4. Number three, the leading term is -2x cubed, so this is a cubic. That means the degree is 3, and our leading coefficient is -2. Number four, all right, our leading term is x to the 4th, and that means we've got a quartic polynomial. Degree is 4, and the leading coefficient is 1. For number 7, our leading term is this one. We've got a quadratic because we have x squared. So degree is 2, and our leading coefficient is the square root of 2, which is a real number, so that's a valid coefficient. All right, number 8. So this is actually it's a line, and it's a horizontal line, which we actually call that kind of function a constant function. It doesn't change for any value of x. If we wanted the degree is actually 0. All right, there's no x, and so that means the exponent on the x is a 0. And the leading coefficient is the same as the constant, which is a -2. Okay, the next section, we are looking at the end behavior for each of the following functions. So we're going to look at two different things. We're going to look at the degree, whether it's even or odd, and then look at whether the leading coefficient is positive or negative. So for number 11 here, we've got odd degree, and our leading coefficient is equal to 1, that is positive. All right, so that means that we are going to have a polynomial that as x gets smaller, goes to the left, the function values, or the graph, is going to go down. And so that's a -infinity. And when it's odd, it does opposite things on either side. So as x gets greater, the graph is going to go up, the function values are going to get more positive. So that's number 11. All right, number 12, we've got even degree. Our leading coefficient is 1, that's positive. Okay, so even degree functions do the same thing on both sides. And since we have positive leading coefficient, it's going to go up on both sides. So we have plus infinity, plus infinity. All right, numbering is a little off. We're going to skip and then we'll go back. But for number 16 here, we've got odd degree, and our leading coefficient is -1, so that's less than 0. All right, when we've got that, we are going to have up on the left and down on the right. So that means as x goes to -infinity, the function values go to positive infinity, and as x goes to positive infinity, function values go to -infinity. 17, x plus 12, that's just a linear function. We can approach this the same way, though. We've got odd degree, right? The degree is 1, and leading coefficient is equal to 1. That's positive, so that means we're going to go down on the left and up on the right. So as x goes to -infinity, function values go to -infinity, and as x values go to positive infinity, function values goes to positive infinity. All right, we have a few more of those. You'll notice that I'm not including everything that's on that worksheet that I handed out, just some of each of the types. All right, 13, we have got even degree, leading coefficient is -1. That's less than 0. It's negative. So that means that we have even degree, so they do the same thing on both sides. So it's going to go down to the left and to the right. So we've got negative infinity for x going to the negative infinity and positive infinity. 14. All right, we have even degree again. It's 6. Leading coefficient is 4. That's positive. So we're going to go up on the left and the right. So plus infinity for x going in both directions. Number 18, again, we have even degree, and our leading coefficient is -1. It's less than 0. So the even degree means it's going to do the same thing on both sides. The negative leading coefficient means it's going to go down on both sides. So negative infinity, both directions. Okay, last one. We've got odd degree. Leading coefficient is a -2. It's less than 0. All right, so that means we go up on the left, down on the right. So as x goes to negative infinity, function is going to go to positive infinity. As x goes to positive infinity, the function goes to negative infinity. Okay, for this next section, we're going to go through each of these polynomial functions and find the x-intercepts, and if we can, from the function, identify what the graph does on the left and right, the end behavior. So let's start off with the x-intercept. So we're going to set the function equal to 0. And solve for x. Factors equal to 0. And solve for x. So we're going to end up with real zeros of x equals 0 and x equals 3. So those are our x-intercepts, so we have 2 of them. All right, now we're going to want to match these up with the graphs on the next page. So let's identify what the graph does, what its end behavior is. So we've got odd degree and we've got positive leading coefficient. So that means that the graph is going to go down on the left and up on the right. Okay, now again, our numbers are kind of all out of whack because just the way the spreadsheet or the worksheet was set up. So the next one we're going to do here is number 26. Let's set that function equal to 0 and solve. All right, this time the common factor that we've got is a -2 and an x. So we bring a -2x out in front. From the first term, we are left with an x squared. And if we take a -2x out of 8x, if we divide that out, we're left with a -4. We have a little more factoring that we can do. That x squared minus 4 is difference of 2 squares. We can write that as x plus 2 times x minus 2. Set factors equal to 0. And solve for x. And we get x equals 0, -2, and +2. So we get 3 x-intercepts. So let's do the end behavior. We have an odd degree, and our leading coefficient is negative. So that means that it is going to go up on the left and down on the right. Okay, number 31. Some of the work is done for us here. It's already factored. We can just set it equal to 0 in its factored form. And then set each of those factors equal to 0. Now, that first factor of -2 doesn't have any x's in it, so that's not going to give us any solutions. But we set the x plus 3 squared equal to 0 and x plus 1 squared equal to 0. Now, to get that x plus 3 all by itself, we're just going to take the square root of both sides. So that's going to give us an x plus 3 equal to the square root of 0, which is just 0. All right, same thing with the x plus 1 squared. Take the square root of both sides, we get x plus 1 equals 0. All right, so solving for x, we're going to get x equals negative 3, x equals negative 1. Okay, it's not as straightforward to determine what the end behavior is here. Now we are able to do that. I'm going to kind of skip over that for now. We'll cover that in later sections. But we get two x-intercepts, negative 3 and negative 1. Let's look at number 22. So f of x equals x. So hopefully you recognize that as the identity function, right? It's just a line, it's linear. But we can set that equal to 0 to get the x-intercept, right? We just set x equal to 0, and there it is, x equals 0. And it's a line, so the degree is 1, so it is going to go down on the right, down on the left, and up on the right. Okay. Here's another one that's already given to us in factored form. So we set it equal to 0. And that means that we can set each of those factors equal to 0. So x minus 1 equals 0, x minus 3 equals 0, x minus 5 equals 0. And then solving each of those, we end up with the x-intercepts of x equals 1, 3, and 5. Now, if we want to look at the degree for this, we can think about what would it be, what would that first term, that leading term be, if we were to multiply that all out? Well, if we were to multiply it all out, the first term would come from taking x times x and then times another x. So the leading term, or the leading term would be a cubed by multiplying all those x terms together. So that would tell us we have a leading term that has degree 3. We have a positive leading coefficient, so that means that it's going to go down on the left and up on the right. Okay, now we're not really to that point where we're multiplying out and trying to figure that out from factored polynomials, but good to know because we'll need to have that for future sections. Okay, let's look at number 32. This one we will need to factor, so set that equal to 0. We can factor out a negative x. That's going to leave a positive x squared, a minus 9. And x squared minus 9, that's the difference of two squares, two perfect squares, so we get x plus 3, x minus 3. So we set each of those factors equal to 0, so we're going to get x equals 0. From the next factor, subtract the 3, so we get negative 3. The next factor, we add 3, so we get a positive 3. Now, end behavior, we've got odd degree, and leading coefficient is negative. So that's going to be up on the left, down on the right. Okay, this next one, we also are in factored form, so we set it equal to 0. And we've got, let's see, this x minus 2 is squared. Okay, so this negative 3, that doesn't have any x's in it, so that's not going to give us any solutions. But the x minus 1 will give us the solution x equals 1. The x plus 2 will give us solution x equals 2. And x minus 3 will give us the solution of x equals 3. So we get 3 x-intercepts. All right, now let's think about what the leading term would be. So the leading term we're going to get by multiplying, right, all of the x's together. But think about this middle term, x minus 2 squared. It's like there's 2 of those. So like I could take away that 2, but if I would have to add another one here. So if I take away that exponent of 2, then I have to multiply by another x minus 2. So I have x times x times x times x. So that's 4 x's. And that's all multiplied by a negative 3. So the leading term is equal to negative 3 x to the 4th. All right, now don't worry about this. We're going to cover this in class in another section, but this will allow us to determine what the graph does on the left and the right, which you're going to be able to match up graphs without doing that. I figured out when I worked through it myself. Okay, so we've got even degree means that it's going to do the same thing on the left and the right. Since that leading coefficient is negative, that means it's going to go down. Okay, as x goes to the left, x goes to the right, function values are going to get smaller. All right, number 28. All right, this one we're going to need to factor ourselves. So negative 2x squared plus 16x minus 24. It's a quadratic, so we're going to know how to factor that. First thing we can do is take out a negative 2. So we're left with x squared minus 8x plus 12. That will factor into negative 2 out in front times x minus 2 times x minus 6. All right, so we set those equal to 0, and we get x equals 2, x equals 6. And we've got a negative out in front of an even degree, so it's going to go down on the left and the right. Okay, now this next one, it looks kind of complicated to try to solve, but if we set that equal to 0, well, first of all, we can factor out a 3 of the whole thing, so let's just do that. Then we're going to be left with x to the 4th minus x cubed minus x squared plus x equal to 0. Now, this is one that we're going to be able to factor by grouping. So we got to go back and remember how to factor by grouping. So we're going to group together these first two terms and then the second two terms. Now we're going to factor out common factors for each group individually. So this first group, x to the 4th minus x cubed, we can factor out an x cubed. And we're left with, in parentheses, x minus 1. All right, in the second grouping, the negative x squared plus x, we can factor out a negative x. And we're left with an x minus 1. Now, that's exactly how we wanted it to turn out, because now we've got this common quantity that's a factor in the first group and the second group, and we can bring that out in front. So x minus 1 times the x cubed from the first group and the minus x from the second group, and that's equal to 0. Now, we still have this 3 out in front. I don't want to forget that. Okay, now, it's not going to give us any solution, so it's okay to forget about it, but it should be there. Okay, we can do some more factoring. We get 3 times the x minus 1, and then we can factor out an x from x cubed minus x, and then we're going to have x squared minus 1 equals 0. Okay, I've kind of run out of room, so I'm going to delete that, get rid of that, and let's just keep going here. So I'm going to bring that x next to the 3, and then we have x minus 1. X squared minus 1, difference of two perfect squares, so that's an x minus 1 times an x plus 1 equals 0. Okay, so we set each of those equal to 0 and solve. We're going to get x equals 0, x equals 1, and x equals negative 1. Okay, this one we've got an even degree and positive leading coefficient, so it's going to have end behavior of going up on both sides. All right, 25. We'll see if we'll do 29 somewhere else, but 25. Okay, it's factored for us. We set those factors equal to 0. We're going to get x equals 0, x equals 3. We want to look at our leading term. All right, we have an x squared times an x cubed. Okay, so adding those exponents, we're going to end up with a leading term of x to the 5th. It's okay if you're not following that. We're going to be able to do this without. So leading term, we have odd degree, positive leading coefficient, so that's down on the left, up on the right. All right, 35 we're not going to do. It's the same as 21. So let's look at doing that one that I just skipped over. Let's see, that was number 29. So 29 is f of x equals negative out in front of x minus 4 times x minus 3 times x minus 1 squared. Okay, it's factored for us, so we can set those factors equal to 0. X minus 4 equals 0, x minus 3 equals 0, x minus 1 equals 0. All right, so we get x equals 4, 3, and 1. So if we want to look at leading term, okay, we multiply the x's, so x times x times x times x, because that one shows up twice. So that's x to the 4th, and then there's a negative out in front, which is going to apply. So our leading term is negative x to the 4th. So we've got even degree, a negative leading coefficient, so go down on the left and the right. Okay, let's look at 24. This one's a little bit different. Here's our case where we don't have an x term. So when we set this equal to 0, we are going to try to get that x squared by itself. So let's add 9 to both sides. So we get 4x squared equals 9. Divide both sides by 4, so we get x squared equals 9/4. We take the square root of both sides, we're going to get x equals plus or minus, right? If we take the square root of 9 over 4, well, that's going to simplify to 3 over 2. Okay, so we get 2 x-intercepts, and our end behaviors, we've got even degree, positive leading coefficient, so up on both sides. All right, number 34. So hopefully you recognize that as a horizontal line, which means that it is a constant function. And the graph is a horizontal line. So it has no x-intercepts. And that should make it easy to match up with the graph. In the next section. All right, number 30. All right, this is our last one. We want to factor this. We can take out an x cubed from both sides. So we're going to be left with x minus 3 equals 0. So we're going to get x equals 0, x equals 3, so those 2 x-intercepts. All right, even degree, positive leading coefficient, so up on the left and the right. Okay, here are the graphs that we want to match those functions with. So let's take a look at these and then figure out which one goes with it. So for number A, or for letter A, we can identify that there are x-intercepts at +1, +3, and +5. All right, now it goes down to the left, up to the right. So if we look back on the functions that we had analyzed, the one that matches up with A is going to be number 27. So this is going to go with number 27. All right, for B, all right, we have a line, and we've got x-intercept of 0. Okay, so that one is going to match up with number 22. Okay, f of x equals x. All right, number C. we've got x-intercept of -2, 0, and +2. All right, and the one that matches up with from our list of functions is number 26. Okay, if you look back, number 26 had those x-intercepts, and we also identified that it goes up on the right and down on the left. Okay, D, we go up on both sides. Okay, so we're going to be looking for an even degree. X-intercepts are -1, 0, and now there is another x-intercept. The graph isn't actually crossing at +1, but it's touching, and that does count as an x-intercept. Okay, and D goes with number 33. Okay, E, we have x-intercepts at -3, 0, and 3. All right, we're also going up on the left and down on the right. So we want to look at what corresponds to that, and that's going to be graph or function number 32. Okay, F. This is x-intercepts of 2 and 6. And we got a parabola there, so that's going to be that quadratic. Which is number 28. All right, G. All right, here's that horizontal line. All right, that one, so there's no x-intercept, and that horizontal line was number 34. And you can see that it's got the y-intercept at oops, wrong thing, -5. All right, H. All right, x-intercepts of 0 and that, and numbers, and 3. And we are going up on both sides. That is going to match up with number 30. All right, I, we've got x-intercept at 0 and 3, all right, same as H, but this time we're going down on the left, up on the right. So we're looking for an odd degree function, and that's number 21. J, x-intercept 0 and 3, again, down on the left, up on the right. That matches up with number 25. K has the x-intercepts of 1, 2, and 3. Again, at 2, it's just touching, it's not crossing, but that does count as an x-intercept. Going down on both sides, so that's that even degree with a negative leading coefficient, and that is number 23. L has x-intercepts of 0, 2, and 4. It's going up on the left and the right, so we'd be looking for an even degree polynomial. It actually is not matching up with any of the functions that are listed there, so this one has no match. All right, M has x-intercepts at -3 and -1. It's going down on both sides, so that's going to match up with a even degree, and M is number 31. N has x-intercepts at ±3/2, and that is the one in number 24. O has x-intercepts at 1, 3, and 4. Goes down on both sides. It's going to be an even degree, and that is number 29.